Welcome to this video. In this video we will learn what is Tyndall effect, why is it caused, where is it used in practical life. So, without any delay, let us move on. The Tyndall effect, also known as Tyndall scattering, is a phenomenon observed when light is scattered by particles in a transparent medium. This scattering of light is responsible for the visible beam of light or a cone of light that becomes visible when particles are suspended in a transparent substance. The Tyndall effect is named after the 19th century Irish scientist John Tyndall, who extensively studied this phenomenon. Here's how the Tyndall effect works. Scattering of light. When a beam of light passes through a transparent medium, such as a gas, liquid, or colloid, a mixture of small particles dispersed in a transparent medium, some of the light is scattered in various directions by the particles within the medium. This scattering occurs because the particles are large enough to interact with and scatter the incoming light waves. Visibility. The scattered light becomes visible when it enters your line of sight. This is why you can see a visible beam of light or a cone of light when light passes through a medium containing small particles. Color and intensity. The color and intensity of the scattered light can vary depending on several factors, including the size and composition of the particles and the wavelength of the incident light. This effect is often more pronounced when the particles are smaller and the incident light has a shorter wavelength, such as blue or violet light. Applications and examples of the Tyndall effect. Atmospheric scattering. The Tyndall effect is responsible for the blue color of the sky. Sunlight contains various colors, wavelengths, and the shorter wavelengths, blue and violet, are scattered more by the molecules and small particles in Earth's atmosphere, making the sky appear blue. Fog and mist. When light passes through fog, mist, or smoke, the Tyndall effect causes the light to scatter, making the fog or mist appear illuminated. This can reduce visibility, especially while driving. Colloidal solutions. In chemistry, the Tyndall effect is used to identify whether a solution is colloidal. If a beam of light is visible when passed through the solution, it indicates the presence of small, suspended particles. Laser pointers. The visible beam of light produced by a laser pointer is due to the Tyndall effect. The laser light interacts with airborne particles, scattering some of the light and making the beam visible. Ocean and lakes. In clear bodies of water, such as oceans and lakes, the Tyndall effect can cause the scattering of sunlight, making the water appear blue or green. In summary, the Tyndall effect is the scattering of light by particles in a transparent medium, resulting in the visible appearance of a beam of light or a cone of light. It is a phenomenon with applications in various fields, including atmospheric science, chemistry, and everyday observations of natural and man-made light sources. The Tyndall effect has several practical applications in various fields of science and technology. Here are some practical uses of the Tyndall effect in everyday life and specific industries. Pharmaceuticals and chemistry. In pharmaceutical laboratories, the Tyndall effect is used to determine the particle size and dispersion of substances in liquids. It helps researchers assess the quality and stability of colloidal solutions, which are crucial in drug formulation. It is used for the analysis and quality control of colloidal suspensions and emulsions. Environmental science. The Tyndall effect can be used to study and monitor air pollution. Laser-based instruments that utilize the Tyndall effect can detect and measure airborne particles, helping assess air quality and pollution levels. Cosmetics and personal care products. In the cosmetics industry, the Tyndall effect is used to create products like sunscreens, lotions, and creams that scatter and reflect light, giving a smoother and more even appearance to the skin. Food industry. The Tyndall effect is employed to assess the quality and stability of certain food products. For example, it can be used to determine the dispersion of particles in milk or to check the consistency of dairy products like yogurt and cream. Lasers and optical devices. In laser technology, the Tyndall effect is used to visualize the path of laser beams. This is seen in laser pointers, where the beam is made visible due to scattering by airborne particles. Atmospheric science and meteorology. The Tyndall effect explains why the sky appears blue during the day. Scientists use this phenomenon to study atmospheric conditions, including the distribution of particles and aerosols in the atmosphere. Hazard detection. In hazardous environments, such as factories or laboratories handling volatile substances, the Tyndall effect can be employed as a safety measure. The visibility of a laser beam can indicate the presence of airborne particles or gas leaks. Biomedical imaging. In medical diagnostics, the Tyndall effect can be used for light scattering techniques such as laser-based flow cytometry and particle analysis to study blood cells and microorganisms. Environmental monitoring. It can be used in environmental monitoring devices to detect and quantify pollutants and particles in the air, water, or soil. Paint and coating industry. The Tyndall effect is utilized to create special finishes and coatings that scatter light in unique ways, producing visual effects such as pearlescent or metallic finishes. In each of these applications, the Tyndall effect plays a vital role in assessing particle dispersion, light scattering, and the optical properties of various materials. It enables scientists, engineers, and industries to better understand and manipulate the behavior of light in practical and beneficial ways. Thank you. If you like this video, please like, share and subscribe my channel Holiday Kid.